My name's Roberta. I'm a waterkeeper at Yellow Quill First Nations. And we've dealt with many problems over the years. This is Debbie, the lady that was originally to present the program. So often in First Nations, people feel powerless to create positive changes in their lives and their community. It is so easy to pass responsibility to the leaders. Okay. That's their jobs, right? They are the ones who are empowered to deal with the outside world. There are advantages and disadvantages of moving into a new community. She moved from her reserve in Eastern Canada to our reserve, Yellow Quill First Nations. Like most reserves, there are never enough houses, so they stayed with their relatives until a house became vacant. The first thing people warned you about at Yellow Quill was the water. Don't drink the water, they tell you. So they didn't. In the meantime, her daughter, then 8 years old, kept getting sick with ear infections, one right after another. She ended up in the hospital because of a severe stomach flu. The doctor never did say from what. Then all the kids in the houses they were staying at got hoof and mouth disease. That was around the time spring runoff was. When she brought her daughter to the local doctor, he couldn't believe what he had saw, and even consulted his medical book to make sure that was what she really had. There were blisters on her hands, feet, and mouth. He told me that he'd never seen this on anybody before. We had no direct contact with livestock. We didn't live on a farm, so where could hoof and mouth be coming from? By this time, she was getting mad. Her daughter was quite healthy before they moved to Yellow Quill. What was going on? It was the water. That's what she felt. That's what she knew. She spoke to other people about this water problem. She asked them how long the water advisory had been in effect. At this time, it had been 5 years. 5 years is a long time, but nobody else seemed mad or upset. It was just the way it was. Maybe after the first year or two, people accepted it, but she just couldn't accept it. She was angry and frustrated because as a mother, she felt she had to do something for her daughter. How could she protect her? She wasn't a band member. She was seen as an outsider. She felt she had no power over the situation. As she spoke to more people, more mothers about the situation, she heard and felt frustrations as well. Even though nothing seemed to be happening at the political level, everybody sure had opinion about the water. A year later, she was working at the health clinic as a wellness coordinator. She was asked to put together a survey that involved the input from the members about health problems and if they drank the water. She was thrilled to be able to do that. She felt like it was progress. The survey concluded that a lot of members had a lot of health problems on the reserve. She was told that the people still drank the water. This is also before INAC provided the resources for the community to bottle its own RO water. This is also the time when Dr. Hans Peterson came to Yellow Quill at the request of an environmental health officer who had just happened to be covering for the permanent environmental health officer. The rookie environmental health officer's impressions of the water situation alerted her that something was terribly wrong with the water and had Hans to give his opinion on the situation. The water situation finally started to move ahead from there. It was about 3 years ago. Today, she is thrilled, and I am also, that the boil water advisory was lifted after 9 long years. Yellow Quill has gone from literally having one of the worst waters in the world to having one of the best. She believed that this is due to the fact that a few people had dared to question and disagree with the experts, such as government officials, consulting engineers, and politicians. These people who we trusted blindly because they know best. They're supposed to be the experts, so we let them make decisions that affect our lives. And why is that? More educated because it's their job to do what's in our best interest. I don't believe education necessarily makes you smart. It certainly doesn't make you wise, and it certainly doesn't make you ethical. We need to think critically about the information experts and governments give First Nation communities. Organizations have their own agendas, which are typically quite different from First Nations. Most organizations want to keep the status quo. It's safe and comfortable, and it's usually in their best interest, not ours. Since obviously the so-called experts and government officials will not change their methods of dealing with First Nations, we must change the way we deal with them. We must remember to listen to our gut feelings, our instincts. That gut instinct is our survival tool. Don't belittle it. I believe we need to set our own standards of excellence, not watered down rules and regulations and guidelines. First Nations have an excellent track record for protecting the land, air, water, wildlife, and the whole web of life. I want to share the story I read in David Suzuki's book, Sacred Balance. A First Nations community was being presented with a 10-year logging plan from a forestry company. The First Nation leadership rejected the 10-year plan. They told the company that a 10-year plan was not good enough. They told them to come back with a 500-year logging plan. This looks like a good start to change the way First Nations deal with the so-called experts. In conclusion, I would like to make the point that I believe Yellow Quill's success in having a state-of-the-art water treatment plant is due to the fact that the community dared to stand up to INAC and not accept a quick fix to the old water treatment plant. Instead, they were able to put together a factual case of why INAC's solution would not work and a subsequent plan that would. With the help and support of the Safe Drinking Water Foundation, Yellow Quill has been successful in achieving a solution that will produce safe, healthy water, not only for Yellow Quill, but could be the future of water treatment plants across Canada. Picture. Okay. Innovation at Yellow Quill. This is a story of Yellow Quill First Nations and how this community of about 1,000 people has gone from having literally some of the worst to some of the best water. Source water came from a small creek that would only flow in the spring and was where a town upstream dumped its treated sewage. Combine this with the rapid water treatment process of coagulation, upflow clarification, and filtration. It's no wonder that this water was unfit to drink and bathe in. Many people's health in the community was affected by this bad water. 5 years into the Boil Water Advisory, there were meetings with Indian Affairs to try and fix this problem. Team effort from the community battled with the officials to find a solution. The team would not accept what was being offered by Indian Affairs, an upgrade to the existing water treatment plant. At this time, Dr. Hans Peterson of the Safe Drinking Water Foundation had been invited to Yellow Quill. Dr. Peterson gave his expert advice to the water team, and things started to move ahead. What do you get when you combine an engineering company willing to try something different, a scientist with a heart of gold, and a First Nations community that would not accept the status quo from Indian affairs? You get a water treatment plant that can process some of the most challenging groundwater in the world and make it very safe and healthy water. After about 18 months of piloting many conventional and unconventional treatment processes, Dr. Peterson found and perfected the process for Yellow Quill. Here's our water plant. Many of you toured it yesterday. Designed to copy nature, but while nature takes days, weeks, or months to carry out this process, the water treatment plant can do it in half an hour. This process is called biological treatment. In contrast to chemical treatment that most other communities use. Instead of using chemical treatment, we rely on natural processes to remove the contaminants. The water is filtered through a sand-like material where natural bacteria from the well water are growing and removing contaminants. After the biological treatment, the water is filtered through a reverse osmosis membrane, which will remove any microbe that is present in the water. The reverse osmosis process also takes out all the good stuff too, like the minerals. To fix this, we run the water through a bed of minerals so as to make it healthy too. In addition of minerals, it also increases our pH and adds protective coating to the distribution pipes. So we have all the good stuff in the water our body needs without sacrificing safe water. I believe this is such a successful and innovative process because it was collaborated between three very different views of life. We are so much more together than we are separated. Thank you.
My name is Larry Cachene. I'm with the Yellow Quill First Nation. And I'll carry on to the next step for the template for change. An issue of trust. What happens when trust is broken? You heard the story of Debbie, our waterkeeper's story on the story that she had coming into a community, her child getting sick, nobody out there to do anything. The political body in our First Nation didn't have the knowledge or the background to do anything with this. And the federal government being not aware of what's happening in our community, you know, all the trust is being broken down from the federal level to the band level and then to our membership, not having trust in their leaders to correct situations that are happening in our communities. And to rebuild that trust, we're going to need time. We're going to need solutions. We're going to need to find out what the problem is in our communities. Like there's some communities here that we've talked to, some of them, and they're having problems in their communities with water. And you're taking the right step here is coming to a conference, listening to the experts, the Safe Drinking Water Foundation and the group that's part of that group are going to kind of help educate and bring the knowledge base back to your community so you know what you're going to be doing when you're going to be rebuilding and trying to rebuild the trust in the communities and try to bring a safe water supply to your communities or improving the supply that's there. What happens to a community that could not trust its tap water due to a nine-year boil water order? You know, the morale in some communities is not where it should be. In some communities, it's lower, and something like this really takes its toll. We have band memberships now in our community that are just starting to trust the system that's there now to provide safe water for our children. And then that's a long road. There was a long battle that some of our members of our political body took to lobby INAC and have facts and information to take so that they can make that change or find a solution for our community. And it also affects the health of the community. Like there was links to certain diseases coming out of the water. There was an information booklet compiled in 1997 or early 98 that had identified, I believe it's over 60 different types of minerals and compounds in our water, and some of those were linked to diabetes type 2. There was arsenic in our water, and there was other carcinogens that were found in there. So there was a whole plateful, I guess, of problems that we had to try and solve, and I think we've done that. And to bring that out to a conference like this, let people know that you guys can do it. Education is the key to do that. So, safe drinking water. How many people get sick and even die from unsafe water? A lot of the experts that are working for the governments, the feds, for the province, Health Canada, they know that there's a very high percentage. I believe it's 90-some% of all illnesses are linked to waterborne, or it's waterborne related. So, but nobody's going to admit that. And in Native communities, I'm sure that's a lot higher because of the standards that are set, the equipment and resources given to First Nations to treat their water or provide a safe drinking supply. You know, is something that was very lacking, and even the experts at INAC. The example I can use is the system that's at Yellow Quill now was designed in 1987, I believe, where we had a reservoir dug up by Pipestone Creek, and the plan was, let's fill that reservoir for the year for Yellow Quill First Nation, and the community accepted that without knowing all the risks and all the dangers that were going to be associated with piping that water down the creek. We had pesticides, we had effluent from the town of Kelvington, just up the creek. And every spring, you know, the water would flow, they'd pump it into the reservoir. Okay, after 9 years, the Yellow Quill First Nation has had the boil water order finally lifted as of March 11th of this year. And like for the people involved in the team, the project team, we had Hans Peterson as part of the team. We had Chief and Council as part of the team. We had technicians from Saskatoon Tribal Council as part of the team. We had a fellow from INAC. I can't say his name. Yoko, I believe, is his first name, but I can't. Don't ask me to say his second name. But after 9 years and after a lot of work and research, and Hans had spent 2 years in our community to do the research that's part of the plant in Yellow Quill. I know there's been a lot of long weekends and long nights that Hans has spent to develop that. So. This is Blaze Neapetung, our water keeper's child. And see, he's got some water there. He's looking confident in drinking it. Okay, who to believe? Even though we now have water that is such a high quality that it surpasses Canadian water quality guidelines and even stricter U.S. Environmental Protection Agency water and quality rules and regulations, some community members are still hesitant to drink the water, going back to trust. It's taken a long time. We've been running the plant since mid-December. And up until about 2 months ago, we were having band members coming up and they had concerns. I know at the beginning they were saying we don't want to be used as guinea pigs when the process started. And now some of these members are still thinking that this water supply is not good because we're using bugs to treat the water. And what's the assurance that we got that those bugs aren't going to get into our water supply? So you go through the process and you explain. You got biological filters to clean the water. Then it goes through the membrane filter, so there's no viruses or any kind of organism that passes through into the supply that's going out into our community. But that's still back to that issue of trust. How can we rely on our politicians in our community when 9 years ago there was a problem here and nobody was alerted, nobody took that and ran with it, and nobody wanted to deal with that situation? It's a little bit different now. It's just to try and convince members that it's a safe supply. And well, I'm saying 2 months ago, there was a lot of doubt. A lot of people doubted the system. Today, we don't hear the comments. People are drinking the water. You know, a couple of months ago, we were talking about having water delivered run through the RO system anyway, and then delivered to each home. And we've done that for 3 years, 2.5 years, doing that. And some of the members wanted to keep doing that. Now we don't hear that in the community anymore. So it's slowly you gotta build that trust back. A United Nations declaration, safe water is such a basic human right. How could such a deplorable condition been allowed to last for so long in the first place? It's, I guess, things are just starting to come to light in Native communities because of the Walkertons happening and things like yellow quill that come to the forefront, and people are aware that maybe the experts that are telling us that this is the plant you need to treat the water in your community, you know, is not adequate. You hear stories like the virus is getting through the green sand filters in North Battleford. So those are awakening people, and I'd like to thank each and every one of you guys for coming and for caring for your communities enough to come and learn about what's being talked about here, and the technologies that are going to be available to First Nations communities, and the resources that if you speak loud enough, you eventually get those resources to address the problems in our communities. Boil water advisories. How often do you hear of boil water orders allowed to last for so long in non-Native communities? Again, back to Walkerton, what was the reaction time of the federal government and Ontario, the province of Ontario, to react? It was almost immediately. You know, and you take the Battleford situation, it was pretty quick that the reaction time was there for governments to step in and let's find a solution to the problem, or identify the problem and resolve it. A lot of times you don't hear of boil water orders lasting 9 years in communities because it's not acceptable anywhere. And in Native communities, why are we forced to accept it? You know, we need to step up and let the people know there is a problem here. Let's fix it. And we have resources out there to help us. We have our technical tribal council people to help us. We have environmental health officers to help us. You know, so we need to alert the right people and do what's necessary. Trust is something that is earned over time. Again, we're going to have to build trust. I know at our table, at the council table, that trust for INAC is not going to be there. The trust that the technicians, there's technicians that work for INAC, and the trust level is going to take a long time for us to come back to our council table when they say this is good for your community, it's good for this community. You know, it's not good enough, and it's going to take time to build that trust, and the trust like we're going to build in our community. It's coming, but we still have to work, we still have to promote, we still have to make people understand the process is safe, you know, and that the supply is safe. You can talk about test results, treatment processes, and state-of-the-art water treatment plants, but to some community members that means little. Going back to what I was saying again is we are assuring people that we have a good safe supply, a good treatment process, and that again takes time to build again. Faith in people. Drinking water from your tap has become a test of faith for some, not only in Native communities, but communities across the country where people are learning more about technology, learning that supplies and systems in place aren't doing the job they're supposed to do. Faith in the treatment process, faith in the water treatment operator. That's all got to be part of the process. Education again. Educating our members about the process, educating that the water treatment operator or the water keeper is the most important member of any community. He holds everybody's safety and health in their hands, so they got to be pretty dependable people. This is Debbie, our water keeper, Blaze Neapetung, and our water plant operator, Robert Neapetung. He's been working at Yellow Quill for I don't know how many years. He's one of our very dependable operators, our most important man in Yellow Quill, along with Debbie and Roberta. Taken for granted. Drinking safe water is not taken for granted anymore or anywhere. That's good to see. You see that in the Native communities. I've talked to some of the people that attended our plant yesterday, and some of the knowledge that's there already. And just to expand on that is a good feeling, and good to know that other communities are caring and learning and doing what they need to do for their communities. You see a lack of trust even in large cities. People getting alarmed, asking questions when they hear boil water advisories or a system has failed, and there again, trust is going to have to be probably not worked on as much as in some smaller communities where they have, like some of the bigger cities have the technology there to treat the water better than, say, Melfort or North Battleford or small little towns in Saskatchewan and Alberta. The bottled water industry is thriving. And why is this? You know, I think everybody is starting to know that water is something that you don't take for granted. It provides good health for you. There's minerals in there that are good for the body. And it also not only keeps you healthy, but emotionally or mentally as well. Keeps your body functioning well. So, and everybody's being aware that drinking that bottled water is better than drinking some of the stuff that we're drinking these days out of small treatment plants. Our mission: promote safe drinking water through supporting innovative research and development, increase awareness of health concerns from consumption of poor quality water, act as a catalyst to ensure that appropriate action is taken to enable the provision of safe drinking water to rural residents all across Canada. And that's the mission of the Safe Drinking Water Foundation. And I'd like to say that Yellow Quill is probably in full support of this mission statement for ourselves and for people across Canada. Do the right thing. Yesterday was the first time I had met Carla Plotnikov. I hope I'm saying that right. The rookie EHO at Yellow Quill humbly states, "I was just in the right place at the right time." She also did the right thing. You too are in the right place at the right time. Will you do the right thing? Go back to your communities and learn about your system and see if there's problems, and let's fix them.
Anyways, I'm just going to go over a little bit of technical background to the project out at Yellow Quill. Oh yeah, I have some philosophical statement before that. From Roberta Jameson, Chief of Six Nations, and one of her people, Dr. Tremblay, will be here on Thursday to present. And Roberta Jameson said, "Water is considered the blood and the soul of life. And contaminated water can poison the blood and affect the soul." And I volunteered as Yellow Quill Scientific Water Quality Advisor for several years to make sure healthy drinking water would be made available at Yellow Quill. And you've heard about Yellow Quill, community about 1,000 people, boil water advisory since 1995, could not be lifted. Here's the location in sort of northeastern Saskatchewan. This is just showing the old reservoir, that water again that we treated in the old reservoir, and the old treatment plant that some of you went and visited yesterday, and the pump station. So the battle at Yellow Quill we showed that the boiled water advisory could not be lifted with the existing treatment system. We did that in 1999, and INAC and the engineering company working on this asked for scientific help, and we started to collaborate in winter 2001, 2002. Pilot study was started in 2002. We looked at 4 surface water sources, 3 groundwater sources, and Yellow Quill groundwater was actually the poorest. Good quality water was 80 kilometers away. But the options we had there was pipe water 80 kilometers, then treat it, lots of money in terms of pipelines, try to treat on-site poor quality groundwater, was the preferred option in the end, simply because of the cost of the other options were too much. And that's how the pilot project was started to treat the Yellow Quill groundwater. And if you look at the aquifer where we took the water out of, we looked at ammonium levels. Actually, some of these are changing as we pump the reservoir. They were initially 4.3 milligrams per liter. They have decreased to 3.7. We look at arsenic. They were actually originally 12 microgram. They've increased to 21 microgram. The iron levels are around 8 to 9 milligrams per liter. And if you look certainly at the Canadian guidelines, way above the Canadian guidelines. Manganese levels are also way above the Canadian guidelines. Also again changing a bit with time. Sodium levels are very high, sulfate levels are very high, dissolved solid levels are also very high, won't even meet Saskatchewan guideline of 1500, and of course won't meet the Canadian guidelines of 500. Dissolved organic carbon levels are also very high, and in the future we'd like to see less than 2. And I want to point out this ammonium, which is, I think you have an ammonium problem in many communities, and you cannot really chlorinate out the ammonium. So ideally, before you treat the water, the ammonium levels should be good. We can use chloramination as a secondary disinfectant, but not until we have properly chlorinated the water. So what we needed to do at Yellow Quill, we needed to remove particles, inorganic ions, dissolved organics, and again, meeting the guidelines is not good enough. And the treatment benefits, again, safe drinking water, high quality water uses for industrial uses, bottling, etc. There's certainly a lot of bottling activities at Yellow Quill right now too. A lot of people coming in and get their bottled water there. And we wanted water with low fouling and scaling potential, and we also wanted legal protection. We didn't want anybody in the community to get sick and get mad at chief and council and cause problems that way. And we would get community approval with good quality water. So again, the treatment, we're producing lead DOC less than 2 milligrams, TDS less than 500, and high barriers for viruses, bacteria, protozoan, parasites. European Union now is certainly talking about extremely high barriers for viruses, running up in the million-fold barriers. So the pilot study was consisting of a self-contained lab trailer. Here you see the trailer with a painting on it. Set up on site, 18 months, 200 liters per minute directly from the well. So the well was just next to the trailer. The systems that we tested were manganese greensand, paralucite, ozone UV, biological filtration, membrane systems, and a few other bits and pieces. Here you can see the inside of the trailer, which kept changing certainly on a monthly basis as some systems were tested, and we decided we weren't going to continue with that and put other types of systems in. And the biological filtration, which you're going to hear a lot more about tomorrow, we are providing a hotel. You can see there on the right top photograph, bugs actually sitting in this hotel, sitting on the surfaces of the biological material. Then you have to provide the right conditions for the bugs. We don't add any bugs to anything. It's simply that we encourage the growth of certain bacteria that will take out the compounds out of the water that we want them to take out. So it's a combination of biological and physical-chemical methods, but the physical-chemical part is less than 10% and the biological is more than 90%. That's when we have it operated at optimum efficiency. And you can see here, you have a contactor with air, they have a biofilter 1, biofilter 2, and biofilter 3, and then to the membrane. We can run them either in 1 and 2, we can run them in parallel, we can run them in series, depending on what we would like to achieve with the biological filtration. Just some graphs showing that for DOC and manganese, we did not intend to remove them by the biological process. And you can see biofilter 1, 2, and 3, low removals, and then the entire removal was done by the membrane. Whereas if you look at some other compounds, like arsenic and iron, we have very high removals of through the biological process. And in terms of ammonium, we are now running the plant as a nitrification plant, and while you have in this scenario you have high levels of ammonium and it's the membrane that takes it out, what it actually is looking like right now is that the ammonium levels are actually removed by the biological filtration and not so much by the membrane. And we anticipate, we just changed the way that was running, and we anticipate to achieve 100% ammonium removal through the biological process sometime in another month or so, which is quite quite good because we are working at very low temperatures, and nitrification, which we're using to do this, is not very efficient at low temperatures, and that we can do that at between 5 and 6 centigrade is quite a feat. So here we now look at some numbers. The biological removal, this was in the pilot, going from 8 milligrams of iron to nothing, and membrane low. Arsenic 12 to less than 2 after the biological treatment, and ammonium at this point was 4 going to about 0.8. We are down now to less than 0.5, and then in the membrane again, after membrane, very low. But we do generate nitrate, and then some of that nitrate is showing up after the membrane, but right now that's it's very low, 10% of what's allowed in the guideline. One of the big things with biological treatment is that in this yellow quill water you have the potential for generating about 400 to 500,000 particles per milliliter. If you just let the water sit in the air, that's how many, 3-4 hours later, you take the raw water and let it sit in the air, you have generated a tremendous amount of particles. In a glass of water you have millions of particles, because in a mill alone you have close to 500,000. But after you've processed it through the biological treatment, you're down to about 60 particles, which is quite interesting, and that's of course why the water is so good then for membrane treatment, because we're taking out all the compounds that could cause us problems for the membranes. And the same with the turbidity. Potential of about 100 NTUs coming out of the membrane, coming out of the biological treatment is about 0.2. Even we have actually problems measuring turbidity. We should go to a laser turbidity meter or something at the very low levels we have to work. And then with membranes though, you still have a lot of salt left in the water, and that's got to be removed somehow, and that's where the membrane, of course, is going to do it. They remove the TDS, they remove the alkalinity, the sulfate goes from, 1,000 to about 2, and organic material, we remove the biologically available organics, and then the remainder is removed by the membrane, and manganese removed by the membrane. So when we use membranes, it must be used in conjunction with other treatment methods. Membrane treatment can remove health and aesthetic components, including microbes, and biological pretreatment ahead of the membranes can remove biological nutrients, providing better quality finished water and less operational problems, including less fouling of the membranes. So this is what we managed to achieve in the pilot trailer, and we were then ready to work with associated engineering, and of course throughout the pilot we worked with associated engineering as well to say, hey, this is a design we need for a large-scale water plant. So the large-scale water plant was based on pilot work. We used air contactor, 3-stage biofilters, RO membrane filtration, pH correction and disinfection. And here you can see, this is as you come into the water comes into the plant at Yellow Quill. And here is a contactor. There's 2 contactors in this picture, a short one and a long one, and the plant can be run in either mode. And these are the biofilters that you see, tall filters there. There are 3 of them. Just like in the pilot, this is just a scaled up version of the pilot. And here is the membrane unit that's come in. And this is something, the pH contactor, most people use sodium hydroxide, soda ash to change the pH. And first, it's a real pain to dump in sodium hydroxide to a barrel. It always splatters no matter how careful you are, so you always get your clothes in a mess. And you also have, it's a, to get that concentrated stuff on you, it's not very good. So we designed something to avoid that, and in addition to not adding sodium, we have designed a mineral bed which is adding calcium and magnesium to the water, and the European Union is now stating that human drinking water should contain a minimum of 20 milligrams of calcium, and that's what we are achieving at Yellow Quill. And then we also have some magnesium in. And in fact, the National Research Council in the US did a study many years ago, like 25 years ago, when they looked at the soft water in the US, and that was not, they didn't have membranes to make the water soft then, but they had naturally soft water, and they made a statement that if to naturally soft water in the United States, if they added calcium and magnesium, they could potentially avoid 160,000 heart attacks every year. But that study was sort of buried, and nobody ever did anything more about it. But I think some of those things are starting to resurface again when we are now more thinking of what we eat and what we would like to have in our water. And that's what the people at Yellow Quill wanted. And again, now this plant is extremely nice to run. Backwashing doesn't have to be very often, every 3 to 4 weeks. And these membranes can run without shutting them down and cleaning them off. And the contactor as well, it can be run. We can run the whole system for a month with no problem, or 3 weeks, whatever it is, till we need to backwash. And then it can be shut down, filter be backwashed, and within another hour you could be up and running again. The one problem we have is that we have no experience in cleaning the membranes, because we've run since December and we have had no fouling of the membranes. And we have the same production and very much the same type of pressures and so forth. So when we come to the stage where we need to clean the membranes, we got to do some thinking on how we're going to do that. But I guess it's a kind of nice problem to have. And I really sympathize with Bob Pratt at Gordon's that, you know, after 3 weeks of running the membranes, we already are starting to foul them, which is a general problem, I think, with some of the pre-treatment strategies that are being used in this province for membrane treatment, and in other provinces as well. And here you see the actually the well site, the treatment plant, and the lab, and this is the distribution pumps. If you look at that plant compared to the old plant and look at what we're doing here now, it's quite a huge difference. Now, there's always been this issue. Granular activated carbon has been a common material to attach bugs to do biological treatment, and they often fines will come through, carbon fines will come through those filters, and they will be populated with bacteria. So you can have high bacterial numbers after traditional biofilters. But we are using expanded clay material, which doesn't have those types of problems. And all the bacteria here in the process are attached to this material. These are biofilm bacteria. These are not planktonic. And with planktonic means they live in the water. These bugs don't like to live in the water. They have to stick to something. They're biofilm bacteria. And like I said here, when you use granular activated carbon as a biofilter material, carbon fines can be discharged into water carrying large numbers of bacteria. It's been a major concern from any granular activated carbon system, actually, and powdered activated carbon even more. So we don't have those fines in these filters. So we have very low bacterial numbers after an expanded clay filter, 50 times lower than the guideline for finished water, actually. Our numbers are very low. You look at here, these are the biofilters. This is full scale again now that were just done in July. Coliforms, nothing, of course. Heterotrophic plate count in filter number 1, 21, filter 2, 4, and filter 3, 8. So extremely low heterotrophic plate counts. With the HPC guideline, it's 500 for drinking water, and that's kind of what we like to achieve. But in the Yellow Quill, of course, we are less in detection. We are down less than 2, because we also have the membrane and we have chlorine after this, right? So removal of compounds in water. Biological filtration can only remove compounds that are either a nutrient or an energy source to the bacteria. The goal is to remove all such compounds so that no further bacterial growth can occur in the membranes. And membrane treated would then remove most compounds without plugging or fouling. And after membrane treatment, it is desirable to add calcium and magnesium back into the water. And here you see mainly biological removal. This is at the full-scale plant. Iron 9, gets down to the bio-treatment to 0.03, and membrane treatment 0.007. Very low levels, so close to detection that it's very difficult to do much with it there. Arsenic has now increased to 21 micrograms per liter in the well. Bio-treated gets it down to 6, and membrane treated lessen detection of 0.4 micrograms per liter. Ammonium, in July we had it running not in nitrification mode. We had 3.7 milligrams of ammonium per liter. We were down to 1.9. That's when we realized we're going to change the way we run it. And within a month we are now down to 0.5, and but then after membrane treatment it's still 0.05, but we expect to have that down to 0 within another month. Phosphorus in the raw we have 0.17, and in the bio-treated very low levels, and same with the turbidity, 100. Potential, I must say potential because we don't generate any particulates out of the raw water at Yellowquill. That's actually one of the key things. We don't want any particles, because as soon as you get particles from iron, the iron has already gone into Fe3+, so it's oxidized. It's of absolutely no use for energy, as an energy source. It's like ashes after you burn a fire. It's like picking up the ashes and think you're going to do something for energy. You won't, but you could use the iron as a nutrient. You can't use it for energy. Well, this plant is based on energy. We need energy for these bugs, so we don't want the iron to come into Fe3+ until the bugs got a hold of it, got the energy. That's what makes this go around. So again, what we do here with the membrane, remove the TDS down to nothing really, goes from 1800 to 17, which is, there's nothing in this water. Of course, then calcium goes from 280 to 0.2, you know. Magnesium, this, you know, less than 0.1, less than detection. So all of those big ions with the membranes, you're going to obliterate them. You're going to take them out. There's going to be nothing left. Manganese less than 0.01, you know, and so forth. So you have a water which is basically H2O, which is quite aggressive. Water that is nothing in it is aggressive. So to recap, biological treatment removes iron, arsenic, ammonium, phosphorus, bioavailable dissolved organics, and turbidity. It also removes sulfide. Reverse osmosis membrane treatment removes dissolved solids including calcium, magnesium, manganese, sulfates, nitrates, and then giving a TDS of virtually nothing. Any remaining ammonium and arsenic ions they will also remove. Dissolved organic carbon, viruses, bacteria, protozoan, parasites. The openings in these membranes are smaller than the smallest virus, so you have an absolute barrier. The problem with reverse osmosis treated water is that the pH is very low. If you have an intact membrane, the pH will be very low. If you have a compromised membrane, the pH may not be so low. And unfortunately, some of the pre-treatments may actually compromise some membranes. And while you still get TDS reduction and so forth, you may not have protection from viruses if they become compromised. So anyways, you have that low pH. It's a very corrosive water, very aggressive water. It needs ions. Like this water just wants to, and you don't want that to be from your stomach. You don't want to do that. So, and you will also leach out copper and lead from plumbing, and you need to make it non-corrosive. And most people would use sodium hydroxide for this. It'll increase the pH, but the water will actually still be corrosive and will have increased sodium content. You should actually add a corrosion control inhibitor if this is the only way that you correct your pH with. So the solution we developed in the end, which looks really simple now, but was an absolute pain to come up with, was a calcium-magnesium contactor, which we worked a lot on to try to figure out how to run that properly. But we are now generating calcium about 20 milligrams per liter, and we have 4 or 5 milligrams or so of magnesium added to the water. No sodium addition. This is a non-corrosive water. A small increase in turbidity after that. And that's from the calcium and magnesium. People that use lime to increase the turbidity typically get levels well above 1 NTU after pH adjustment like that, and we are about at half an NTU. But after membrane treatment, we are less than 0.1, and so the entire addition is from the minerals. We are trying to figure out how we could do that without having any increase in turbidity afterwards, but we haven't resolved that yet. So you can see here we actually are increasing the TDS. TDS of 17 is too low, it's too corrosive, you don't want to have it, more than if you are in a lab and wants to have really good lab water. Calcium goes from 0.3, nothing really, to 21, which is great. Magnesium goes from nothing to 3. Now, trihalomethane in this water is 5 micrograms per liter, 20 times lower than the Canadian guidelines. Dissolved organics are now below 0.2. They're below the detection level. Color is less than 3, heterotrophic plate count less than 2. Turbidity goes from 0.09 to 0.49. And again, I must say that we also have problems measuring the turbidity, and we need to go to a laser turbidimeter as we work with very low levels of turbidity. So the conclusions is that the biological filters effectively removes compounds that bacteria can use, resulting in a biologically stable water with no further bacterial growth being possible. The RO membrane filtration units have experienced little fouling due to the biofilters, 10 months without cleaning, and removes most remaining compounds as well as particles, including microbes. The combination of biological filtration and membrane filtration was successful for the treatment of low-temperature groundwater and provided a simple and robust operation without chemical addition, apart from low-level antiscalant addition, pH adjustment, and chlorine. High biological efficiency due to large surface area of the filter-light material, cost-effective treatment, even for an extremely poor quality water source. Thank you.